Why do we study the context for software development? Why do we look at the forces that lie beyond the merely technical questions that we address with our skills, with our knowledge, with our tools? Hi, this is David Allen Greer for the Errant hashtag, and today's episode is entitled The Means of Production. In the study of software development, Ralph Flanders is a minor historical figure that's connected to the anchor of agile methods only through a long chain of many rusted and incomplete links. He's generally known, when known at all, as a business leader and a politician. His briefest moment of glory came in 1954, when he introduced the motion into the U.S. Senate that would censure his colleague, Senator Joe McCarthy. Yet early in his career, after he had served an apprenticeship as an industrial engineer, he identified several key problems that hindered industrial productions, problems that continue to hinder and bedevil software development. The connection between industrial engineering and software development is actually quite strong. The early software developers, including John von Neumann's colleague Hermann Goldstein, shaped their notions of software with concepts that they took from industrial production. The word program, for example, came from the term that described a plan for factory operation. Flowcharts came from the diagrams that traced the movement of material through a plant. Sequencing originally referred to the steps of factory operation. Program quality and the software lifecycle borrowed from work to develop production plans that would create uniform goods. Flanders did most of his engineering in the 1920s, when Henry Ford was the dominant industrial engineer. Ford argued for production methods that placed the workers under strict production control. Each worker had one place in the production line, did one job repeatedly, and, he hoped, eventually learned how to be efficient with that job. Flanders argued that such an approach was ill-suited to the production of many products. He claimed that the most challenging problems of manufacture were not to be found with inefficient workers, but with manufacturing overhead. He wrote that many plants saw only a modest increase in output when they switched to Ford's methods, and yet these plants saw great increases in overhead, particularly in the number of foremen and the amount of clerical labor they were called upon to do. Flanders made recommendations that are familiar to anyone who has followed recent trends in lean and agile methodologies. He urged manufacturers to organize production by product, not by process, that they design their product to be as simple as possible. He suggested that factories use small teams and encouraged team members to develop wide and comprehensive sets of skills. Finally, he recommended that the groups work as independently as possible, so that the group leader would be able to supervise the work rather than attend to the labors of meetings and memos and reports. The foreman is bounded only by his production orders and his schedule, he stated. Within these limits, he is king of his territory. Flanders appears to have had limited influence as an engineer, though his ideas may have been thwarted first by the reduced production of the Great Depression, and second, by the overwhelming demands of the Second World War. However, his concern for technical leadership echoed through the engineering literature. It was picked up by management consultant Peter Drucker in the 1950s, the Russian engineer S.P. Mitrofanov in the 1960s, and of course, by software engineer Frederick P. Brooks in the 1970s. A major part of the cost of software, wrote Brooks, is communication and correcting the ill effects of miscommunication. Hence, he concluded, computer software needs to be built by as few minds as possible. Technical leadership remains one of the great problems of software production, for it requires a different set of skills than those that are needed for conventional mid-level management. skills that typically handle the tasks of planning, allocating, and coordinating assets and work. Technical leaders, by contrast, need to understand the details of their product, teach key skills to their workers, assess the output of their team. Excessive communication, coordination, and reporting reduces the efficiency of these leaders, often fatally so. So why do we care about Ralph E. Flanders? We care about him because he cared about technical leadership long before it was fashionable to have such concerns. Like many who followed him, he recognized that such leadership was difficult and that we could make it easier only by finding better ways of organizing the means of production. This is David Allen Greer for the Errant hashtag. Take care.